The Theory of Political Economy by William Stanley Jevons. Chapter 4 Theory of Exchange Part 10 Symbolic Statement of the Theory. To represent this process of reasoning in symbols, let delta x denote a small increment of corn and delta y a small increment of beef exchanged for it. Now our law of indifference comes into play. As both the corn and the beef are homogeneous commodities, no parts can be exchanged at a different ratio from other parts in the same market. Hence, if x be the whole quantity of corn given for y, the whole quantity of beef received, delta y must have the same ratio to delta x as y to x, and we have then delta y over delta x equals y over x, or delta y equals y over x times delta x. In a state of equilibrium, the utilities of these increments must be equal in the case of each party, in order that neither more nor less exchange would be desirable. Now the increment of beef delta y is y over x times as great as the increment of corn delta x, so that in order that their utilities shall be equal, the degrees of utility of beef must be x over y times as great as the degree of the utility of corn. Thus we arrive at the principle that the degrees of utility of commodities exchanged will be in the inverse proportion of the magnitudes of the increments exchanged. Let us now suppose that the first body, A, originally possessed the quantity A of corn, and that the second body, B, possessed the quantity B of beef. As the exchange consists in giving x of corn for y of beef, the state of things after exchange will be as follows. A holds A minus x of corn and y of beef. B holds x of corn and B minus y of beef. Let phi1 A minus x denote the final degree of utility of corn to A, and phi2x the corresponding function for B. Also let psi1y denote A's final degree of utility for beef, and psi2 B minus y B's familiar function. Then, as explained on page 96, A will not be satisfied unless the following equation holds true. Phi1 A minus x dx equals psi1 y dy, or phi1 A minus x over psi1 y equals dy over dx. Hence, substituting for the second member of the equation given on page 95, we have phi1 A minus x over psi1 y equals y over x. What holds true of A will also hold true of B, mutatis mutandis. He must also derive exactly equal utility from the final increments, otherwise it will be for his interest to exchange either more or less, and he will disturb the conditions of exchange. Accordingly, the following equation must hold true. Psi2b minus y dy equals phi2x dx, or substituting as before, phi2x over psi2b minus y equals y over x. We arrive then at the conclusion that whenever two commodities are exchanged for each other, and more or less can be given or received in infinitely small quantities, the quantities exchanged satisfy two equations which may be thus stated in a concise form. Phi1 A minus x over psi1 y equals y over x equals phi2x over psi2b minus y. The two equations are sufficient to determine the results of exchange, for there are only two unknown quantities concerned, namely x and y, the quantities given and received. A vague notion has existed in the minds of economic writers that the conditions of exchange may be expressed in the form of an equation. Thus John Stuart Mill has said, "The idea of a ratio as between demand and supply is out of place, and has no concern in the matter. The proper mathematical analogy is that of an equation. Demand and supply, the quantity demanded and the quantity supplied, will be made equal." Mill here speaks of an equation as only a proper mathematical analogy. But if economics is to be a real science at all, it must not deal merely with analogies. It must reason by real equations, like all the other sciences, which have reached at all a systematic character. Mill's equation, indeed, is not explicitly the same as any at which we have arrived above. His equation states that the quantity of a commodity given by A is equal to the quantity received by B. This seems at first sight to be a mere truism, for this equality must necessarily exist if any exchange takes place at all. The theory of value as expounded by Mill fails to reach the root of the matter, and shows how the amount of demand or supply is caused to vary, and Mill does not perceive that, as there must be two parties and two quantities to every exchange, there must be two equations. Nevertheless our theory is perfectly consistent with the laws of supply and demand, and if we had the functions of utility determined, it would be possible to throw them into a form clearly expressing the equivalence of supply and demand. We may regard x as the quantity demanded on one side and supplied on the other. Similarly, y is the quantity supplied on the one side and demanded on the other. Now when we hold the two equations to be simultaneously true, we assume that the x and y of one equation equal those of the other. The laws of supply and demand are thus a result of what seems to me the true theory of value or exchange.